In today's world, enterprises have become increasingly interested in containers, and to properly configure a container architecture, we need strong networking skills. And this introduces the concept of Docker networking. So hello everyone, this is Sahiti on behalf of Edureka, and I welcome you to this session on Docker networking. So thank you all the attendees for joining in today's session. Before we get started, all of you just give me a quick confirmation on the chat window whether I'm audible or not. Okay, I've got many yeses, so that's great. So without wasting any further time, let's look into the topics for today's session. We'll start today's session by understanding what is Docker and Docker containers. After that, I'll tell you what exactly is Docker networking and then discuss the goals of Docker networking. Then, I'll talk about the CNM model, that is the container networking model and its objects, and finally end the theory part of the session with a discussion on network drivers. After the theory part is done, I'll then move on to a hands-on part where we'll deploy a multi-tiered application over a Swarm cluster. Alright guys, so is the agenda clear to everyone? Okay, so that's great. So now let's get started. So let's start with the first topic for today's session, that is what is Docker. Now, to understand Docker, you have to first understand how applications were being deployed before and then now how applications are being deployed nowadays using containers. So as you can see on the screen, the left side is the architecture which was used to deploy the applications before. So your operating systems will have a kernel, and that is the only thing that's going to be common between all the applications. You can see the blocks here, right? So these are basically the containers and these are isolated from all the other applications. So application 1 cannot access the libraries of application 2 and vice versa. So the application and its necessary libraries and binaries are isolated from rest of the systems so as to ensure that this environment is constant and is not being encroached by any other application. So all the files and the necessary libraries are all packaged with the application itself and are isolated from the other applications. So Docker is an open platform for developing, shipping and running applications. Docker enables you to separate your applications from your infrastructure so that you can deliver your software really quickly. Now, as I was talking so much about containers, let me brief you what a container is. A container platform is basically a complete solution that allows the organizations to solve multiple problems across the diverse set of requirements. So, it is more than a piece of technology and orchestration which delivers sustainable benefits throughout the organization by providing all the pieces of enterprise operation requires, that is including security, governance, automation, support and certification over the entire application lifecycle. So, Docker Container Platform enables IT leaders to choose how to cost-effectively build and manage their entire application portfolios at their own pace without the fear of architecture and infrastructure lock-ins. So, multiple containers run on the same machine and share the operating system kernels with the other containers, each running as an isolated process in user space and also taking up less space than the virtual machines. Now, you must be wondering how these individual containers communicate between each other in various situations, right? How do these isolated processes communicate with each other to fulfill your task? So, well, that comes through none other than Docker networking. So, before I deep dive into what exactly is Docker networking, let me show you the workflow of Docker. Alright guys, so this is the general workflow of Docker. So, a developer writes a code that defines all the application requirements and dependencies in an easy to write Docker file, and this Docker file produces Docker images. So whatever dependencies are required for a particular application is present inside this image, and then when we run this Docker image, it creates an instance and that is nothing but the Docker containers. This particular image is then uploaded onto the Docker Hub. So from these repositories, you can pull your image as well as you can upload your images onto the Docker Hub. Then, from the Docker Hub, various teams, just the quality assurance team or the production team, will pull the images and prepare their own containers as you can see from the diagram. Now, these individual containers will communicate with each other through a network to perform all the actions required, and this is nothing but Docker networking. So what exactly is Docker networking? So when containers are created, these isolated containers have to communicate between each other, right? So the communication channel between all the containers introduces the concept of Docker networking. Alright, so now what would be the goals of Docker networking? So Docker is flexible. In other words, I mean pluggable. By flexibility, I mean that you can bring in any kind of applications or operating systems or any kind of features in Docker and deploy them in Docker. Next, Docker can be easily used in cross-platform. By cross-platform, I mean you can have n number of containers running on different operating systems, like one container can run on the Ubuntu host, other container can run on the Windows host, etc. like that, right? So you can have all these containers work across with the help of Swarm clusters. After that, we have Docker offering scalability. As Docker is a fully distributed network, it makes the applications grow and scale individually. Then we have Docker using decentralized network. This enables the capability to have your applications spread and highly available. So in the event that a container or a host is suddenly missing from your pool of resources, we can automate the process of either bringing up additional resources or passing over to the services that are still available. Apart from offering the decentralized network, we have Docker being really user-friendly. So Docker makes it really easy to automate the deployment of your services or containers that would make things easy for you in your day-to-day life. And finally, we have Docker offering out-of-box support. So the ability to use Docker Enterprise Edition and getting all the functionalities very easy and straightforward makes Docker platform to be very easily used. So those were the goals of Docker networking. Now, to enable these capabilities, we have the container networking management, and to do that, we have the libnetwork. Now, what is this libnetwork? So libnetwork is an open source in which you can read through the source code and you can automate all of that as an open source. So libnetwork is basically a Docker library that implements all of the key concepts that make up the CNM model. Now, what exactly is this container network model? Well, container network model formalizes the steps required to provide networking for containers while providing an abstraction that can be used to support multiple network drivers. So CNM requires a distributed key value store like console to store the network configurations. The container network model has interfaces for IPAM plugins and network plugins. The IPAM plugin APIs are used to create or delete address pools and allocate or deallocate container IP addresses, whereas the network plugin APIs are used to create or delete the networks and add or remove the containers from networks. A container network model is basically built on three main components: the sandbox, endpoints, and the network object itself. So a sandbox contains the configuration of a container's network stack. This basically includes the management of the container's interfaces, routing tables, and DNS settings. Now, a sandbox may contain many endpoints from multiple networks, right? An endpoint is something which joins a sandbox to a network. Endpoint can belong to only one network but may only belong to one sandbox. And finally, as I was talking about network is a group of endpoints that have the ability to communicate with each other directly. Now that you know a brief about the container network model, let me tell you the various objects involved in this model. The container network model comprises of 5 main objects: the network controllers, drivers, network, endpoint, and sandbox. Starting with network controller object provides the entry point into the libnetwork that exposes the simple APIs for users such as the Docker engines to allocate and manage networks. Since libnetwork supports multiple active drivers, both inbuilt and remote, network controller allows users to bind a particular driver to a given network. Next comes driver. Driver is not a user visible object, but drivers provide the actual implementation that makes the network work. Driver can be both inbuilt and remote to satisfy various use cases and deployment scenarios. The driver owns a network and is responsible for managing the network, which can be further improvised by having multiple drivers participating in handling various network management functionalities. After the driver object, we have the third object as network. Network object is an implementation of the container network model. As I said, network controllers provide APIs to create and manage the network object. Whenever a network is created or updated, the corresponding driver will be notified of the event. The libnetwork treats network object at an abstract level to provide the connectivity between a group of endpoints that belong to the same network and then also simultaneously isolate them from the rest. The driver performs the actual work of providing the required connectivity and isolation. The connectivity can be within the same host or across the multiple hosts. After that, the next object that we have is endpoint. As I discussed before, endpoint mainly represents a service endpoint. So it provides the connectivity for services exposed by a container in a network with other services provided by other containers in a network. So the network object provides the APIs to create and manage endpoints, and an endpoint can be attached to only one network. Since endpoint represents a service and not necessarily a particular container, endpoint has a global scope within the cluster as well. And finally, we have the sandbox. So the sandbox represents containers network configurations such as the IP address, MAC address, routes, and DNS entries. A sandbox object is created when the user requests to create an endpoint on the network. The driver that handles the network is responsible to allocate the required network resources such as the IP address and pass the info called as sandbox info back to the lib network. So, the lib network will make use of the OS-specific constructs to populate the network configuration into the containers that is represented by the sandbox. So, a sandbox can have multiple endpoints attached to different networks. Alright guys, so that was a brief about the various network model objects. Now, let me tell you the various network drivers that are involved in Docker networking. Docker networking has mainly 5 network drivers involved with it: the bridge, host, none, overlay, and MACLAN network. So starting with the bridge network is the default network driver. So if you do not specify a driver, then this is the type of networking you're creating. So the bridge network is a private internal network created by the Docker on host. All the containers are attached to this network by default. The containers can access each other using this internal IP, and if it is required to access any of these containers from the outside world, then port forwarding of these containers is performed to map the port onto the Docker host. Bridge networks are usually used when your applications run in standalone containers that need to communicate. Another type of network is the host network. This removes the network isolation between the Docker host and the Docker containers, and then it uses the host networking directly. So, if you were to run a web server on port 5000 in a web app container attached to the host network, it is automatically accessible on the same port externally without requiring to publish the port, as a web container uses the host network. This would also mean that, unlike before, you will now not be able to run multiple web containers on the same host on the same port, as the port are now common to all the containers in the host network. The third option is the none network. The containers are not attached to any network and do not have any access to the external network or the other containers. This is usually used in conjunction with a custom network driver and is not available for Swarm services. The next network that we have in the list is overlay network. So to understand this network, let's consider a scenario. Let's say we have multiple Docker hosts running containers. Each Docker host has its own internal private bridge network in the 172.2.17 series, allowing the other containers running on each host to communicate with each other. However, containers across the host have no way of communication with each other unless you publish the ports on those containers and set some kind of routing yourself. This is where the overlay network comes into play. With Docker Swarm, you could create a new network of type overlay, which will create an internal private network that spans across all the nodes participating in the Swarm cluster. We could then attach the containers or services to this network using the network option while creating a service, and then we could get them communicate with each other through this overlay network. So, you can say that you can use overlay networks to facilitate communication between a Swarm service and a standalone container, or between two standalone containers on different Docker daemons. And finally, we have the last network, that is the MACLAN network. So MACLAN networks allow you to assign a MAC address to a container, making it appear as a physical device on your network. Then the Docker daemon routes traffic to the containers by their MAC addresses, and then the MACLAN driver is sometimes the best choice when dealing with legacy applications that expect to be directly connected to the physical network rather than routed through the Docker host network stack. So guys, that was about the various network drivers. Now let me brief you a little bit about Docker Swarm and tell you the significance of Docker Swarm in Docker networking. In simple words, if we have to define Docker Swarm, then Docker Swarm is a cluster of a machine all running on Docker. This provides scalable and reliable platforms to run many containers, which enables the IT administrators and developers to establish and manage a cluster of Docker nodes as a single virtual system. So, as we know that Docker Swarm is a technique to create and maintain cluster of Docker engines, what exactly is this cluster of Docker engines? So let me tell you that in a cluster of Docker engines, there will be many Docker engines connected to each other forming a network. This network of Docker engines is what is called as a Docker Swarm cluster, as you can see from the diagram on the screen. And this is also the architecture of Docker Swarm cluster. So there will always be one Docker manager. In fact, it is the Docker manager which basically initializes the whole swarm, and with the manager, they will have many other nodes on which the server should be executing. So there will be times when the service is also executing at the manager's end, but the manager's role is to make sure that these services or the applications are running perfectly on the Docker nodes. Now, whatever applications or services that are specified or requested, they will be divided and then they would be executed on different nodes, as you can see in the diagram here. So these different nodes are nothing but the workers. Alright guys, that's all you need to know about Docker networking. Now let's move on to the hands-on part. In our hands-on part, first I'm going to show you how to create a simple network and how to deploy the service over your network. And after that, we'll create a swarm cluster and then we'll connect two services and then we will scale a single service. Alright, so let's get started with our hands-on. So first, we're going to deploy an application named Apache 2 by creating a Docker service in the default network, that is the bridge network. So apart from that, we'll also initialize the swarm cluster as we want it to work on two different nodes, that is the manager node and the worker node. So for that, let me open my terminal and then let me type in the command sudo docker swarm init --advertise -addr and then mention the IP address, right? So I'll mention the IP address of the manager node and then I'll click on enter. Once you click on enter, you'll be asked for the password. So type in the password and then you can see that the swarm has been initialized. Now to connect the slave node to this particular manager, you have to copy this link and then go to the slave node, open the terminal and then paste it here. So you can see that this node has joined the swarm as a worker. So that is the manager and this is the slave. Now let's go back to the manager node and over here, we're going to deploy an application named Apache 2 by creating a Docker service. So for that, you have to type in the command docker service create --name, give the name of the application, --mode, that is which mode we want it to work. We want it to work in the global mode, -d, -p, that is port forwarding, and then we'll mention the port where it's going to work. So it's going to work on 8003 and then mention the account name from which the Docker image has been pulled. So once you click on enter, you can see that your Docker service has been created. Now to check whether your Docker service has been created or not, you can use the command docker service ls. So this will list all your running services. At present, we just have one service, that is Apache 2. Now to check whether it is running or not, you have to go to the slave node and then open the web browser here and then let's go to the local host to the port 8003. So let's go to the port. So you can see a message that it works. So that means our application has been deployed onto a container and then it is also connected to the swarm cluster. So the worker also has this particular application. Now, if you want to deploy a multi-tier application in a swarm cluster, how will you do that? So let me show you how to do that. So before I do that, let me tell you what are we going to connect. So basically we have two applications, that is the web application and the MySQL database. So the web application has two parameters, that is the course name and the course ID. And once you mention the details and you click on submit query, it will be automatically stored in the MySQL database. This multi-tier application is connected with each other through the overlay network. So let's start doing it. So first let's create the overlay network. So for that you have to type in the command docker network create -d overlay my overlay 1. So my overlay 1 is basically the name of the network that I'm giving. You can give any other name that you want. After that, let's create a service for the web app application. So for that, I'll again type in the command docker service create --name. Name of the application is web app 1 -d --network, and we'll connect it to my overlay 1 network, and then -p for port forwarding, and then we'll mention the port on which it is going to run, and then we'll mention the account details from which this Docker image will be pulled. So after that, you can just click on enter. So you can see that your Docker service has been created. So let's check it once again. So for that, you'll type in the command as docker service ls. So you can see that the web app 1 service has been created. Now we'll create another service for the MySQL application. So for that, you'll type in the command docker service create --name MySQL, that is the name of the application, -d --network. The network through which we want to get connected is my overlay 1 -p for port forwarding. Let's mention the port, and then the account details. So for that, let me mention the account details. So you can see that your Docker service has been created. So let's check again. So for that, we'll type in the command docker service ls, and you can see that the MySQL service has been also created. Now what you have to do is you have to go to the web app application, and inside which you have to make some changes. So to go inside the web app service, you need to know the container ID. So to know the container ID, you have to type in the command docker ps. So this will list all the container IDs that are present on this node. So you can see that web app 1 and Apache 2 are present. At present, we need container ID for web app 1, right? So to go inside this container, you'll type in the command docker exec -it, and then copy this container ID and then paste it here, and then end the command with bash. So you can see that you've gone inside this container. Now you have to go to a file index.php and make some changes. So for that, we'll type in the command nano and mention the directory. So this PHP file opens up. Now you have to change the server name to MySQL since we want to get connected to the MySQL server, and then change the password to Edureka. And let's say we keep the database name as hands-on. After that, use the keyboard shortcut Ctrl X, press on Y, and then save the file. So once you're done with this, you have to exit the container. So for that, type in exit, and you can exit the container. Now you must have observed here that only the web app and the Apache 2 services can be seen on this node, whereas we are not able to find the MySQL. That is because it is present in the slave node. So let me show you there. So let me go to the terminal, type in docker ps, and you can see that the MySQL service is over here. So why is that so? That's because Swarm is performing load balancing. It is dividing its containers into 2 different nodes so that it can balance the load properly. So now what you have to do is you have to go inside the MySQL container. So for that, you'll type in the command docker exec -it, and then mention the container ID of this particular container, and then end the command with bash. So you'll go inside this particular container. Now once you're inside this particular container, you need the access to use MySQL commands. So for that, you'll type in the command mysql -u root -p edureka. So once you type in this command, you can see that you've got the access to use the MySQL commands. So -u is basically the user, and -p is for the password. And if you have a question that why are we using -it here, that's because we're opening the container in the interactive mode. So once you get the access of MySQL, you have to create a database, and then you have to create a table inside it. So for that, you'll use the MySQL commands such as create database hands-on, and then you have to use that database. So for that, you'll type in the command use hands-on. So you can see a message that the database has been changed. Now you have to create a table. So for that, type in the command create table. Let's say courses is the name of the table, and then mention the 2 parameters. So we have course name, which is of varchar type. Let's say it allows a length of 15 characters. And let's say we have course ID of varchar types of 12 characters. And after that, close the bracket. And this creates a table for you. After that, you have to exit your MySQL connection. So for that, you'll type in exit, and then you have to again come out of this container. So again, type in the command exit, and you'll be out of this container. Now what you have to do is you have to go to the slave mode and then run this index.php file. So for that, let me open localhost. Since the web application service was running on 8001 and index.php file. Alright, so you can see that our Docker sample app has been opened up. Now before you include the details, let me go back to my web app container and let me show you what all I've changed in the file. So you have to mention the server name to be MySQL, your username to be root, password to be your password, and then database what I've mentioned there, that is hands-on. And the name and ID would be the parameters that I would give. So it would be course name and course ID. And then you have a basic PHP file in which you write the SQL command that insert into the course name and the course ID, which will basically include the details that we fill into the application to be stored directly into this table. Now let's go back to the slave node, and now let's mention some details. So let's say we mention a detail to be blockchain and the course ID to be randomly some number, and then we'll submit the query. Once you submit the query, you can see that a new record has been created successfully. So let me just create few records. Alright, so I've typed in few records. Now let's go back to our MySQL container and get into the database and see if our table has all the records entered, stored or not. So let's go back to the terminal. So now let me type in the command docker ps, and then I'll type in docker exec-it, mention the container ID. Now I'll type in the command mysql-u root-p edureka. So this will give my MySQL connection. So now I'll type in the command as use hands-on. So database has been changed. Now I'll type in the command as show tables. So it will show me the tables that I've included in database. So I have this table included. Now let me type in the command select star from courses. So this will basically list all the details that are stored inside this table. So you can see that we have entered so many details with the help of this web app, and that were directly stored into our MySQL database. So guys, that's how you can, connect multi-tier applications over the overlay network. Now, if you want to scale any particular service, you can just scale that service by using a simple command. So for that, you have to go back to your manager node and then use the command docker ps to list all the containers. Alright, so we have two containers. Let's suppose we want to scale this web app service for around 5 times. So you can do that with a simple command, that is docker service scale web app 1 is equal to 5. So you can see that the web app 1 service has been scaled to 5 times. Now, if you want to check whether it is working or not, you just have to type in the command docker service ps web app 1. So you can see 5 instances of the same services. So guys, that's how you can deploy a simple application over the default network and also connect multi-tier applications with an overlay network, and finally you can scale any particular services. So guys, that was a short demo on Docker networking. That's all for today's session. Thank you and have a great day.